So hi and hello. Welcome to our channel name Algo Exploration. My name is Samir. Now from today onwards we are going to learn problems related to binary search. Okay, so since this is a first lecture, okay, so I'll be keeping it very simple. Here we just have to find whether the element is present or not in an sorted array. So let's take one array in which here we need to find the element 93. Okay, so if we want to find the element 93, there are two approaches. First one would be that it can be found using linear search. Okay, and the second one would be binary search. Okay, linear search is pretty simple. We just have to compare each and every element with the target. Okay, if we found that the target is equal to value, then we found our answer. So simply return true, otherwise false. Okay, using linear search in a sorted array takes order of n time, and the space complexity takes constant amount of time. Okay, now let's try to explore what is binary search. So the binary search approach comes by the observation of going to a particular page in a book. So we know that in a book, okay, all the pages are in a sorted order. Okay, so let's consider that the number of pages in a book is of 100 pages and we want to go at page number 40. Okay, so we don't actually flip all the pages one by one until we reach page number 40, right? It's stupidity. So basically we just open the book from the middle. Okay, so let's say we are at 51 after opening from the middle. Okay, now we will be comparing 40 and 51. Okay, we found out 40 is lesser than 51, so we go left, in which our search space will be from page number 1 to 50. Okay, initially it was from 1 to 100. Now the search space is become half. Okay, so observing this behavior only, the binary search was introduced. Okay, so the first step would be find the middle element, and the simple formula for finding the middle element will be take the higher index and lower index and add them and just divide it by 2. So here in this case the higher index is 8, the lower index is 0, divided by 2, the answer will be 4. Okay, this will be the first step. The second step would be check whether the middle element is equal to target or not. Okay, so here the middle element is 12, right? Because 4 a of 4 is 12, right? So we will be checking whether it is 93 or not. There will be two cases, either it will be equal or not. Okay, if it is equal, then simply return true. And if it is false, if the middle element is not equal to target, then there will be two cases. First, check if the middle element is greater than target. If the middle element is greater than target, then we know that the element which we want to find is present on the left hand side of that search space. So go left. Okay, and how we can go left? Simply do higher index is equals to mid minus 1. Okay, and if this is not the case, that means if mid is lesser than target, then we know that the target value is present on the right hand side. So go right. And this can be done by doing low is equals to mid plus 1. Okay, so these are the two steps. Okay, let's try to dry run this by taking this example only, in which the target value is 93. Low, high, and mid. Initially the low is 0, high is 8, mid will be 8 plus 0 by 2, that will be 4. Okay, now we will be checking whether a of 4, that is 12, is equals to 93 or not. Here in this case it is not, false. Then we will be comparing 12 and 93. We got to know that 12 is lesser than 93, so go go right. If you want to go right, then the low should be mid plus 1. So the low will be 5, high will be as it is. Now again find the middle element. So 8 plus 5 divided by 2, that will be 6. Okay, I'm just taking the integer value. Okay, so a of 6 is 53, and we do know that 53 is lesser than 93. Then simply go right again. That means do low is equals to mid plus 1. Again, low will be now 6, high will be as it is. 6 plus 8, sorry, 8 plus 6 divided by 2. The answer will be 7. What is a of 7? It is 58. Check. That means compare. 58 is lesser than 93. Again, go right. That means do low equals to mid plus 1. So low will be 8, high will be also 8. 8 plus 8 divided by 2, that will be 8 only. Check. A of 8, that is 93. Is 93 equals to 93? 93? Yes, it is. So return true. So in this way, we will be solving this problem. Okay. Now let's try to take one more example. Okay. So here, let's imagine that the target is 108, not 93. Okay. So till this, we are on the right page till this point. Okay. We will be comparing 93 and 108. We found out 93 is lesser than 108. Okay, so it means that we need to go right again. That means do low equals to mid plus 1. Okay, so we'll do that. So low will be 9 and high will be as it is 8. Now we can see that low is greater than high. Okay, if that's the case, then we have to return false. Okay, so now let's try to design an algorithm. So the first, I will be designing an iterative approach. Okay, we have seen that if the low is greater than high, then we have to return false. Okay, in which if low is lesser than equals to high, then only we can enter inside the loop. So initially low will be 0, high will be n minus 1. Okay, while low is lesser than equals to high, then only I will be entering inside the while loop. Okay, now the first step will be find the middle element. So mid equals to high plus low whole divided by 2. Then check if a of mid is equals to target. If that's the case, return true. Otherwise, check again if A of mid is greater than target. If that's the case, where do you want to go? On the left hand side. So do high equals to mid minus 1, and there will be else case as well. In this we have to go on the right hand side. That means A of mid is lesser than target. So low would be mid plus 1. That's it. And if you found out that low is greater than high, then we simply need to return false. So return false. Okay, so this was the iterative approach. Now let's try to design a recursive approach as well. So I'll be actually naming this function as binary search. So binary search, in which I will be passing an array A, low, high, and target. Initially, the value of low will be 0 and the value of high will be n minus 1, okay, which will be coming from main function. Now, as usual, we will be checking the anchor condition, okay, otherwise it will be going to the Stack Overflow. If high is lesser than low, if that's the case, then return false. This will be anchor condition. If it is not, then first step would be find the middle element. Mid will be high plus low whole divided by 2, right? Check if A of mid is equals to target. If that's the case, then we have to return true. Right? If it is not, then else if check A of mid, if it is greater than target, then where would be the target lying? It will be lying on the left hand side. So go left. Okay, so since this is a recursive approach, okay, so we will be calling a function itself, okay, and that would be binary search, in which we will be reducing the search space. Initially the search space was from 0 to 8. Now here in this case, if we got to know that the element is present on the left hand side, so the search space would be 0 to 3, okay, because mid was 4, okay, and we have to go on the left hand side. So due to that reason, A will be as it is, low will be as it is again, but here the high will be different. So mid minus 1 and the target as it is. And since we have to return the value, so return it. That's it. This was the else if. Okay, and else, that means mid value is actually lesser than target. So in this case, we have to go on the right hand side. So go right. That means return binary search in which A will be as it is here. Now since we have to go on the right hand side, so the low will be mid plus 1, high will be as it is, and target. Okay, and that's it. Yeah, done. This was the recursive approach. Now if we talk about the time complexity and the space complexity of both these approaches, it will be pretty simple. See, every time we are actually dividing the search space by 2. Okay, so due to that, the time complexity for both the approaches will be order of log n. Okay, and talking about the space complexity of this approach will be order of 1. Okay, now you have to comment it down that what would be the space complexity of this binary search. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.